Chapter 1. Introduction. Scenario: imagine that in 2025 the U.S. is fighting a rich, but now consolidated, politically powerful drug cartel in South America. The cartel has purchased hundreds of Russian and Chinese-built fighters that have successfully thwarted our attempts to attack their production facilities. With their local numerical superiority and interior lines, the cartel is launching more than 10 aircraft for every one of ours. In addition, the cartel is using the French system probatoire d'observation de la Terre (SPOT) positioning and tracking imagery systems, which in 2025 are capable of transmitting near real-time, multispectral imagery with 1-meter resolution. The U.S. wishes to engage the enemy on an uneven playing field in order to exploit the full potential of our aircraft and munitions. Meteorological analysis reveals that equatorial South America typically has afternoon thunderstorms on a daily basis throughout the year. Our intelligence has confirmed that cartel pilots are reluctant to fly in or near thunderstorms. Therefore, our Weather Force Support Element, WFSE, which is a part of the Commander-in-Chief's SYNC Air Operations Center, AOC, is tasked to forecast storm paths and trigger or intensify thunderstorm cells over critical target areas that the enemy must defend with their aircraft. Since our aircraft in 2025 have all-weather capability, the thunderstorm threat is minimal to our forces, and we can effectively and decisively control the sky over the target. The WFSE has the necessary sensor and communication capabilities to observe, detect, and act on weather modification requirements to support U.S. military objectives. These capabilities are part of an advanced battle area system that supports the warfighting SYNC. In our scenario, the SYNC tasks the WFSE to conduct storm intensification and concealment operations. The WFSE models the atmospheric conditions to forecast, with 90% confidence, the likelihood of successful modification using airborne cloud generation and seeding. In 2025, uninhabited aerospace vehicles, UAV, are routinely used for weather modification operations. By cross-referencing desired attack times with wind and thunderstorm forecasts and the SPOT satellite's projected orbit, the WFSE generates mission profiles for each UAV. The WFSE guides each UAV using near real-time information from a networked sensor array. Prior to the attack, which is coordinated with forecasted weather conditions, the UAVs begin cloud generation and seeding operations. UAVs disperse a cirrus shield to deny enemy visual and infrared (IR) surveillance. Simultaneously, microwave heaters create localized scintillation to disrupt active sensing via synthetic aperture radar (SAR) systems such as the commercially available Canadian Search and Rescue Satellite-aided tracking (SARSAT) that will be widely available in 2025. Other cloud seeding operations cause a developing thunderstorm to intensify over the target, severely limiting the enemy's capability to defend. The WFSE monitors the entire operation in real time and notes the successful completion of another very important but routine weather modification mission. This scenario may seem far-fetched, but by 2025 it is within the realm of possibility. The next chapter explores the reasons for weather modification, defines the scope, and examines trends that will make it possible in the next 30 years.